today we're going to be talking about the unit circle. We're going to be doing the very basics. We're setting up this idea of a unit circle, and we're going to mostly be talking about the basic trig functions. Alright, so in geometry you started off a little bit with the trig functions. So we have sine, cosine, tangent, and then we have the reciprocal functions, which are cosecant, secant, and cotangent. So just going to kind of talk about these real quick, just as a refresher. And those of you who have not done this before, then hopefully it'll give you, it'll get you caught up. All right, so let's talk about standard position again, right? We've been talking about standard position for trig in a while. So we start on the positive x-axis, and then we have an angle. All right, so let's make this into a little triangle here. So let's say we draw a line from this point on the radius or the ray down to the x-axis, and let's make it a right triangle. So it's going to be perpendicular to the x-axis, the line that we just drew. All right, so if you remember from geometry, we had this thing, so katoa, right? And it was a mnemonic that helped us to remember the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Right, so when we're dealing with trig, we're going to always be looking at the angle that's formed inside here, and this is called theta. This is called theta. It's just a symbol. It's a circle with a line through the middle of it. It's a Greek symbol, and it's just what we use in trig a lot of times to denote that we're looking at this angle in standard position. All right, so if we're looking at our triangle in relation to theta, then the side across would be the opposite side. The side next to it that's not the hypotenuse would be the adjacent side. And the hypotenuse is always the ray. It's always the longest side. Alright, so if we look at this, let's just kind of make some definitions here, or make a little table here about the 6 different trig functions. So the 6 different trig functions: the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and then the tangent is going to be the opposite over adjacent. So hopefully this is ringing a bell. We could even do an example here. So let's just draw a triangle here. And you don't have to, well, you should write this down, but it's not part of our work for today. And let's say this side is going to be 3 units, the bottom is going to be 4 units, and the hypotenuse is going to be 5 units. If we want to find the 6 different trig ratios here, what we're going to do is we're going to say sine is opposite over the hypotenuse. So the opposite side, our theta is always in here. The opposite side is 3. Over the hypotenuse, which is 5. The cosine is the adjacent over the hypotenuse, so the adjacent side is 4. The hypotenuse is still 5. And then the tangent, which is the opposite over the adjacent, is 3/4. Alright, so it's pretty straightforward. We just take the length of the side and plug it into your formula. Now, once we get those done, the reciprocals are quite easy. Let me make a little bit of space here. So they're called reciprocal functions because they're just the reciprocal of the functions that they're related to. So the sine reciprocal function is cosecant, and we're just going to flip our fraction. Cosine's reciprocal function is the secant, so we'd also just flip the fraction. And cotangent as well is the reciprocal for tangent, and we're going to flip the fraction for that one. So that's how we come across the 6 trig functions. We find the first 3. These are the basic ones. And in order to find the last 3, we're just going to reciprocate because these are the reciprocal functions. Alright, so now let's talk about the unit circle a little bit. So the unit circle has a radius of 1, right? So 1 means unit. Unit circle meaning radius 1. Alright, so if we take a look at this circle, all it is if we started standard position, we know that all along this circle, our radius is going to be 1 because the radius won't change. Alright, we can also think about our unit circle as a circle being centered at the origin of a coordinate plane. So this is the y-axis, and this is the x-axis. Alright, so in order for us to find the unit circle and its sides, the opposite side, the adjacent side, what we know is the hypotenuse here is always going to be equal to 1 for our unit circle, as long as they specify that. Now, our opposite side if we're looking at this point here, the height of that point is just going to be y. So the opposite side is y. The adjacent side is going to be our x. So now let's rewrite these trig functions, 6 trig functions, in terms of x and y. So sine is going to be the opposite over the hypotenuse, but because our hypotenuse is 1 and our opposite is y, sine is just y. So whatever our y value is from our point on this unit circle, the sine is just going to be the y value. Okay, so likewise, cosine equals, well, cosine is adjacent over the hypotenuse. The adjacent we said was equal to x, so it's going to be x over hypotenuse is always 1. So the cosine is just going to be the x value from whatever point we're looking at. And then tangent is the opposite over the adjacent. Well, our opposite's y, our adjacent's x. So whenever we're looking at this at a unit circle and we know a point on that unit circle, all we have to do is put the y value over the x value. That will give you your tangent. Now let's do the reciprocal functions, right? So we know that the cosecant theta is equal to the reciprocal of y, so that's just going to be 1 over y. Right, we just took our value y from the sine and reciprocated. Same thing with cosine and secant. So we're going to reciprocate. Secant is 1 over x, and then tangent would be the reciprocal function is cotangent, and the reciprocal of y over x is x over y. Alright, so that's the basic setup for what we're going to be doing today. So let's do an example. All your problems are going to be similar to this one. So let's say that we're given this point on the unit circle, -1/2 square root of 3 over 2. It's asking us to find the 6 trig functions. Okay, so the first thing we want to do is we want to label this x and y. X and y. As you guys get better at it, you probably find that you don't have to label it, but I think that starting off, it'll help you guys out a lot. So let's write this again. You guys don't have to write it if you already have it from the other page, but sine theta equals y, cosine theta equals x, tangent theta equals y over x, and then we're going to do the reciprocals. The cosecant is reciprocal of sine. Secant is the reciprocal of cosine. And then cotangent is the reciprocal of tangent. Alright, so let's start finding these 6 trig functions. Sine is straightforward. Sine theta in this case is going to be our y value. That's square root of 3 over 2. Cosine theta is also pretty straightforward. It's our x value, which is -1/2. And then our tangent equals square root 3 over 2, which is our y, over our x, which is 1/2. Now, most of you are probably familiar with what to do with complex fractions. If you are not, from Algebra 2, that's fine too. Just remember that this fraction bar here means that we're dividing the top by the bottom. And going all the way back to the beginning of algebra, we know that division is the same as multiplying by the reciprocal. So we're going to take this number, radical 3 over 2, times the reciprocal of the denominator. So the reciprocal would be -2 over 1. Alright, so the 2's will cancel. 2 divided by 2 is 1. And then we have our negative sign still left over. And then square root of 3 over 1 is just square root 3. Okay, so we have our first 3 trig functions, trig values. Now let's do our reciprocal. So the reciprocal of sine is cosecant. And we're going to reciprocate this. The reciprocal of cosine is secant. We're going to reciprocate -1/2. The reciprocal is -2 over 1, which is just -2. And then the cotangent is going to be -1 over radical 3. Alright, and then you're done. So that's what you're going to be doing today. Eventually, we're going to talk about what happens if we have a square root in the denominator and how we can fix that. So like in those two examples. But for now, I just want us to focus on being comfortable with finding the sine, cosine, tangent, and then reciprocal functions, cosecant, secant, and cotangent. So make sure you have your notes down, make sure they're all good to go, and any questions you have, you also have written down so we can talk about them the next class. Good job today. I will see you next time.